This is a brief introduction to the basic features of the eCHT code, which I spoke about in the eCHT seminar on the 30th of September. This is the first of 3 videos. This one shows how to define a module and how to compute a minimal resolution for it. The modules we're going to use as our samples are those which occur in a little Cofiber sequence here. Let's let M be the cohomology of BO1, which is this 4-cell complex. So the M itself has 4 generators over F2 in degrees 0, 4, 6, and 7, with a square 4 connecting the bottom 2, and then square 2, and then square 1. We're going to look at the Cofiber sequence this sits in, which has Cofiber new sitting at the bottom and the 6 suspension of Cofiber 2 at the top. And this, when we apply cohomology to this Cofiber sequence, we get a short exact sequence here, where M1 is the smallest module in which square 1 is non-zero, M4 is the smallest module in which square 4 is non-zero, and M is the module up here. Now, the way the eCHT code works, the F2 generators of a module are numbered, starting with 0. So the 4 generators in M will be numbered 0, 1, 2, and 3. We'll come back to that in a minute. And what we'll see in the second lecture will be, demonstration, will be how to compute the induced maps in eXT coming from this. But first, let's just create the modules. Okay, so what we're going to do is create the module definition files for these 3. We'll use the command new module to install them. In the process, we'll show how to use, how to enhance the sort of obvious parts of the definition to get the complete definition. And then we'll compute the resolution, collect all that data, create Adams charts for them, and then we'll actually join all 3 Adams charts into one. So just a nice little demonstration of how the Adams charts are designed to be used. Okay, so let's go to a directory where we can do all of this. I have one called cohom test. And since we're going to be working with A modules rather than A2 modules, we're going to go down into the directory A. Now, we want to create the first module M1. Okay, so I am going to create a file m1.def, and the module definition file for M1 says that there are it's 2-dimensional over F2. The 2 generators are on degrees 0 and 1, and there's a generator 0 has a square 1 acting on it, which has 1 term in it, and that consists of generator 1. And that's the end of that. So now that we've got that, we can install it. Tell the computer new module M1. Oh, and here's an interesting feature of all the commands. If you invoke the command with the wrong number of arguments, it'll tell you how it's to be used. And so this tells you that new module needs the name of the module. That's going to be the directory in which the resolution is computed and stored. And module def is the module definition. Okay, so M1 will be the directory, and we'll use this file I just created, mod m1.def. Okay, it created the directory. When it checked the module definition for correctness, it had no errors to report. So we can just go down into M1 now and compute. Let's go from dimension 0 to 40. That'll be nice and quick. And I'm going to run this in the background so I can do some other things at the same time. Okay, so now let's go back up to, notice we're in M1's directory. I'm going to go back up to the Steenrite Algebra A's directory now, and I will create M4. Okay, so its definition looks like 2 generators. Now these are in degrees 0 and 4, and generator 0 has a square 4 on it, which consists of 1 term, and that's generator 1. Okay, so new module M4, m4.def. Okay, again, no problems. We'll go down into M4 and start computing. Oh, I have to actually type it correctly, though, don't we? We'll start the, what do I mean dot dot? CDM4, Robert. Okay, there we are. Okay, so now let's compute the resolution from degrees 0 to 40 for this as well. And again, we'll run that in the background. If I actually look at what jobs are running, I can see both of these are still running here. Okay, so now let's go back up to the A modules directory. And let's start creating the middle, the module definition file for the middle module. Now, if I think about this, there's some obvious entries here, namely the square 4, the square 2, and the square 1. So first we tell it has 4 generators. They're in degree 0, 4, 6, and 7. On generator 0, there's a square 4, which is 1 term, and it's generator 1. On generator 1, there's a square 2. It has 1 term, and that's generator number 2. On generator number 2, there's a square 1. It has 1 term in it, and that's generator number 3. If you remember the ADEM relations, you'll know that that's not actually going to be the whole story, but we'll see that happen automatically. So let's go. Okay, so let's install the module now. New module, m dot definition I just created. Now, when we see here, when it was checking the module definition for correctness, it reported some errors. So let's go down into the directory for M and see what they are. This program new consistency will tell us the old program consistency just gives us a very brief summary of what's wrong. Here it says the ADEM relation that starts out square 2, square 4, when applied to generator 0, didn't produce 0 like it should have. Okay, new consistency tells us also what the whole ADEM relation is. Okay, so the ADEM relation is square 2, square 4 plus square 6 plus square 5, square 1. Applying that to the bottom generator here, we see that square 5, square 1 is obviously 0. There's nothing in degree 1. Square 6, well, we didn't define a square 6, and that's the problem. Square 2, square 4 took us from generator 0 to generator 2, and square 6 should do the same. So let's go and look, let's go into the definition now and fix that. I will add a square 6 here, which takes generator 0 to generator 2. All right, so now, okay, by now you see also both of the other jobs are done. Job 1 is done and job 2 is done. So the other 2 resolutions have been computed out to degree 40. Okay, let's, we've already done that step, Robert. Okay, so now let's run new consistency and see how it likes it. Well, it's still not good. Okay, so what's the problem now? Square 1, square 6 plus square 7 applied to generator 0 is non-zero. It should be 0, of course. So, okay, so we go back into the definition, and there we go. There's the problem. We should have had a square 7 here as well. Okay, so we add that, and that gives us generator 3. And, you know, we know the ADEM relations well enough. We also know there should be a square 3 on this guy. Generator 1 here. So let me just put that in right now. So generator 1, apply square 3 to it. That takes you to generator 2, and then from there to generator 3. Okay, so it should be correct now. Let's run new consistency, and sure enough, no errors are reported. Okay, so now we can go ahead and compute the resolution for this module. Set that going. Well, now that the resolutions for M1 and M4 are done, let's go up there and compute the create the files for those. Okay, so let's go back here to our little summary of what we're doing. Okay, so we've used new module to install them, and we're using DIMS to compute the resolutions. Now, using a report, we're going to collect the data it's generated and create Adams charts using chart. Okay, so we go over, we're down in M1 now. So report, that could produce a text summary of the output as well. We don't really want that today. So if you want more details on any of this, you can go look at the paper that John Rogness and I put on archive when we posted the database at the IRD database repository. And it just gives a more complete description of file formats and all of these techniques. Okay, so chart, let me show you the invocation. You give it the high and low, the low and the high filtrations, the low and the high geometric degrees. This file shape and HI mults, those actually were created by report. So let's look at those. Here are the files that were most recently created. After creating all these differentials and computing the resolution, we have it created the command report generated the file shape and the file HI-mults here in particular. Those are the ones that we need for the charts. Okay, so now let's go back and create the chart. Let's go from filtration 0 to 12. That's fairly low, but I'm gonna fit all of these into a single file in a minute. So that'll be more convenient. And then HI-mults. Now, the next one is the output file. Let's just call this m1.tech. And then the label that goes into the caption, the tech caption for the figure that it generates. So I'll just call it M1. All right. So now that we've got that chart, open is the sort of generic Mac command to do whatever is appropriate to the file, and that's m1.tech. Open will fire up tech shop for me. We'll typeset this. And if you're at all familiar with the mod2 morph space, this should be quite familiar here. These lightning flashes connected by news, hooking the bottoms of the lightning flashes together up along the edge, and then some more stuff here. Okay, and you can see that we calculated out to internal degree 40 and stopped there by this vanishing line along this edge up here. Okay, so put that to sleep for the moment. Let's do the same thing in the other two directories. Okay, report. Always should do that to bring all the data up to date here. And then chart, I'm going to just use practically the same chart command because I want the same size of tech figure here. But now I'll call it M4. Now let's look at M4.tech. Typeset that. Okay, now this may be slightly less familiar. This is the Cofiber of new. Okay, you see we killed off new in the 3 stem here. And then it starts, the effect of that, of course, is to create a 4 cell, a dimension 4 generator starting in filtration 3 here. And we'll look at this in more detail in a minute. So now let's go to the third module we created, M, and again, run a report to collect the data. And now the chart command, now I'll just call it m.tech. Okay, typeset this. Okay, and this may be even less completely familiar. But you can see the effect of killing off the new and with the 4 cell, and then actually we killed off Ada on the 4 cell here, etc. Okay, now next thing I want to show you is how to use these tech files. And in fact, I don't really need m.tech anymore, so I got rid of that. Let's copy. Okay, let's think about this for a second. We have Cofiber new going into B01 with quotient sigma 6 of Cofiber 2, giving us this long exact sequence. So let's put the Cofiber of new at the top of the page, B01 in the middle, and M1 at the bottom, and then the connecting map will, and then the induced maps in ext, induced by these module maps or by the geometric maps from Cofiber new to B01, etc. Those will map those 3 X down the page, and then the boundary map will go from the bottom around to the top. Okay, so let's do that now. Let's copy m.tech into, let's call it LES for long exact sequence. Oh, let's not do that. Let's actually first put M4 .tech in here at the top, and then we'll add the others after that. Okay, now. Okay, so I've got, and now let's just add m.tech to the end of les.tech. And let's add m1.tech at the bottom. And let's go in and edit First, I'll open this so we can just watch what it looks like. Okay, if I typeset this, of course, all we're going to see is that first Cofiber new sitting here at the top, because we'll see in a second. Let's go in and look at the file now. Okay, so you can see here at the top, there is just a tiny little bit of tech header before it starts to do this tick-Z picture here. So the tick-Z picture is the vast majority of this. So what we'll do now, if you go down to the end of this, you'll see the end document here has caused it to only display M4. So we'll get rid of the end document there and the tech header. And now we'll start in the new figure for m.tech in the middle. If I now write this out and retypeset this, you'll see it's now added m.tech there. And you can kind of see what the induced map is going to look like from Cofiber new into B01 here already. Now let's go ahead and get rid of the other end document and incorporate the rest of this m1.tech into here. Okay, so now let's make this a little bit bigger and move it over to the middle of the page. And there we go. This gives us the line exact sequence in ext corresponding to this Cofiber sequence that we started with here, Cofiber new to B01 to sigma 6, Cofiber 2. And that's it. I will, in the next section, in the next video, I will show you how to start creating the map definition files that link these up.